So welcome everybody. This is the June 2024 installment of the Microsoft Data Continuity Platform virtual group. I really appreciate you all joining, especially with this being kind of the summer and everybody's off on vacations. So we always really appreciate it. With me today are two absolutely amazing gentlemen from Microsoft. We got Haider, Raza, and Manish Kumar talking about Azure SQL PaaS Unveiled and a lot of different cloud-based database options on the Microsoft Azure platform. So with that, I'm going to turn it over to you guys.
Great. Thank you very much, David. And good morning, good afternoon, everyone. I hope you can hear me okay. I understand it's summer season, so just wanted to keep the topics hot as well, so that you don't miss summer. So let's start with the introduction. So I'm Haider Raza. I'm a cloud solution architect at Microsoft. I'm in IT for more than 25 years. It's been a long journey, most of the time in data and AI. And at this point, I'm going to switch off my camera. Just, that's enough. You have seen me enough. So let's move on to the slide deck. Okay, so what we are going to talk about today is SQL. Obviously, that's our favorite topic. But before that, I'm going to let Manish introduce himself. Manish, are you on?
Yes, yes, it is unmuted. Hi, everyone. This is Manish Kumar. I'm Senior Cloud Solution Architect with Microsoft, and I'll be co-presenting with Haider today. Yeah, that's me, Haider. You can continue.
Thank you very much, Manish. Okay, so the overall agenda is pretty straightforward. We kept it as simple as possible. So we are going to talk about Azure SQL services on Azure as a platform as a service options. And then we'll talk about business continuity. So that's what we are planning to cover today. Please feel free to ask any question you have as we go, because I feel it's sometimes easier to answer at that point in time and easier to ask as well at that point in time. So yeah, feel free to ask any question or drop into the chat. So let's start with the SQL services on Azure. Okay, but before we talk about SQL, one of the things people ask about, okay, what is this Azure region? What is this availability zone? They are always kind of some confusion. Okay, what the difference between the two? So I thought let's put together this slide that might help you to understand a little bit better. So Azure region, obviously, as the name says, is a region. Usually is not documented anywhere, but usually the regions are apart about 300 miles minimum. So that it caters for any big problem like weather problem, disaster, natural disaster, etc. So that's the region, roughly 300 miles apart. Within Azure region, we have what we call availability zone, and it's not available in every region. But as far as I know, at this point in time, most of the region has availability zone available. So within Azure region, we have 3 availability zones. And the whole idea of having availability zone is kind of building a data center within a region which are independent of each other, but still very close to each other. Okay, so they will have completely independent power supply, network cable, water supply, AC, everything is completely separate. So they are independent of each other. But the main advantage is that the latency, because they're close to each other, you get a much better latency. So you get latency of less than 2 milliseconds. And that's really a big plus for customer who wanted to set up a high availability disaster recovery. But at the same time, they don't want to have it too far. That will take too long to fail over. So that's what availability zone is. And because you could have your high availability or disaster recovery span across region as well. So you can have within region, within availability zone, but also across another region and another availability zone. So that's what it is. And again, this is another thing which I thought it might be worth highlighting, that when we talk about Microsoft, we only think about SQL or Windows, but Microsoft provide platform as a service option for many databases, many operational databases. We're talking about here operational databases. So when it comes to relational databases, we have SQL family, we have Azure SQL family, and we have open source databases. Okay, these are all open source databases, community edition, no fork out, there's no tie-up, lock-in. It's exactly the same community version you get it, but it's fully supported platform as a service options. Then we have Azure Cosmos DB, which is non-relational database, and we have in-memory database, which is Redis. So this is just to give you an idea. There are a lot more databases Microsoft support other than SQL. Okay, let's now jump into SQL. So when we have SQL Server on-prem, you have 4 components. Okay, SQL Server Engine, SSIS, SSRS, and SSAS, Knowledge Services. But when it comes to Azure, they have been segregated. So they have been segregated in 4 different areas, and we have platform as a service of solution, platform as a service option for all of them, or most of them, I would say. But when we talk about SQL, SQL platform as a service option, we talk about SQL Server Engine. So everything I'm going to cover in the next slide, it's all about SQL Server Engine. Okay, so now SQL on Azure. So what are the options available? So there are 4 options available. You can run SQL Server exactly the way you have on-prem on Azure VM, which is infrastructure as a service option. Exactly same SQL Server, all the 4 components I mentioned earlier, those 4 components are available. You can manage the way you want. You are responsible for making sure it's up to date. You're responsible for planning the upgrade, from 2014, 2016, 2019, whatever it is. But you get the full SQL Server exactly the same way you have on-prem. When it comes to platform as a service option, broadly speaking, there are 2 options, and we are going to cover today these 2 options in detail. And there is a SQL on Edge, which is basically catered for IoT applications. Let's talk about SQL Managed Instance. So what is SQL Managed Instance? So SQL Managed Instance is a platform as a service offering, and platform as a service offering means you don't need to worry about taking the backup, recovery, etc. It's all taken care of that. So all those kind of mundane activities, all those kind of DBA activities which DBA hate, taking the backup, applying the patches, restore, that's all taken care of that. It's completely platform as a service option is a full SQL server surface area. And what does it mean? That when you have a SQL server running on-prem, you have SQL Server instance, and with an instance, you have multiple databases. Okay, so you have exactly the same setup as SQL Managed Instance on Azure, and you have other services surrounding like SQL Jobs, etc. Those are also available on SQL Managed Instance. Is always up to date, means you don't need to worry about which version of SQL I'm going to have. Is always going to up to date. You would never need to even think about the current version of SQL Server you are running on. High availability is already built in, so you don't need to build in. You can still go for a hot replica, which we'll cover in that. But the high availability is built in, always on, based on always on concept. SLA is 99%, 99.99% SLA is out of the box, and some of the built-in intelligent performance and security. So we have invested a lot into security, into improving the performance, and those capabilities are already there. Another things I would like to highlight, this is SQL Managed Instance specifically catered for customers who would like to migrate their existing SQL Server to on-prem, from on-prem to Azure. And that's why I say that in most of the cases, virtually no code changes to your application, when you migrate your SQL Server from on-prem to Azure. So that's a SQL Managed Instance. There is another flavor of SQL Managed Instance called SQL Managed Instance Azure Arc Enabled. What is Arc Enabled? Arc Enabled is the capability where there are customers who would like to keep their application on-prem because of whatever reason, because they wanted to keep it close to their customer, because there's some regulation requirement, whatever it is. But this Arc would allow them to manage the database the way they want on-prem, but they want to get all the benefit of platform as a service option, all the benefit of Azure. And that's what Arc Enabled is. That means is exactly the same SQL Managed Instance platform as a service offering. You don't need to worry about applying patches. You don't need to worry about taking the backup, etc. And you are managing at your own premise. So that's SQL Managed Instance. Now, how do you deploy it? So there are two service tiers when it comes to deployment. General purpose and business critical. General purpose is catered for most business workload. The major difference between the two is the storage. So for the general purpose, the storage is remote. Okay? Whereas business critical, the storage is on the same VM where you're computed. So the storage is local. And that's why you have much better IOPS in business critical than general purpose. The another advantage of business critical is you get a read-only replica where you can direct your read-only query direct to there, and you don't pay extra for that. So there is a read-only replica which comes with the business critical. So you can direct all the read-only queries there, and you have got multiple secondary replica you can create. So you can have in some situation where customers say, I want another replica in a different region because my customer is close to that, and I wanted to redirect all the read-only queries to that replica, which you could do that. So that's the business critical. So just general purpose business critical, the two options available for deployment, SQL Managed Instance on Azure. Now, what I'm going to show you is some of the demo for SQL Managed Instance. And as I said, please ask any question you have. I don't want to keep it very, like a lecture. I don't want to keep it as a lecture. So yeah, please feel free to ask any question. So this is portal. You go to portal.azure.com. I'm sure most of you have seen it. Now you search for Azure SQL. And when it comes to Azure SQL, I've got already some of them created. That's why it's showing me all the list. But if I go and say I wanted to create one, so say create, and now it's going to show me different options available on Azure for SQL. Now I'm interested in SQL Managed Instance at the moment. So let's create a new SQL Managed Instance. So there are two options here. As I mentioned earlier, you can create a SQL Managed Instance or SQL as an Arc. That also you can create a Managed Instance. The SQL Managed Instance I want to create. Let's go for that. Now, one of the things I want to highlight here, which is really useful, and I found lots of customers very useful. You can get a free SQL MI for I think a year or for 12 months. Yeah, for 12 months. So it's great if you want to play with the SQL Managed Instance, if you want to do development. Obviously, you would not be deploying it on production because you can't get a support for that. But this is a great tool where you can learn SQL Managed Instance, build your own application for free. You don't pay anything. So this is there to use. Okay, so Now, what you need to specify here, obviously, you need to specify the resource groups you want to use it, and then you specify the region you want in. Okay. Now, this is interesting here for your compute and storage. So you specify what kind of compute and what kind of storage you want. So let's configure it. And this is where I was talking about the two options, general purpose and business critical. So if you go for general purpose, this is next gen features available for general purpose, which is in preview, and that's why we are giving option for customer to enable or disable it. So let's keep it disabled for now. Here you have option to choose different hardware generation. So there are 3 generation of hardware available, and the major difference between all 3 are the RAM per vCore. So here is for Gen 5, you have 5.5, 1 GB for premium series is 7 GB for memory optimized premium series is 13.6 GB. So you can pick up whatever suits your application. And here you can specify how much core you want, and that's how the price will change. And you specify the storage. Okay, so that's the general purpose. Another thing to highlight here is that if you have a SQL Server license on-prem, which you would like to bring on, you can use Azure hybrid benefit, and that means you're using your SQL license from on-prem. You're not paying it here. So the cost is here is for the VM, etc. Yeah. So that you have to confirm it. Another thing is zone redundancy is also available. I think is in preview at the moment. So the zone I was talking about earlier, that there are 3 different availability zone within region. So if you want to create another replica of your SQL management instance within an availability zone to take the advantage of low latency, less than 2 millisecond latency, as I mentioned, you could do that, but that your backup storage has to be either zone redundant, and that's what it's saying here in this, or a geo zone redundant. So if that is the case, you have to pick up, and then you can select zone redundancy. You can enable zone redundancy. So that's what it is for general purpose. For business critical, exactly the same thing. The main difference here that if you see secondary replica is already available. It's included in the price, so you don't pay twice here. So in general purpose, if you create a replica in another availability zone, you pay for the secondary replica. Here is business critical, you don't pay. It's already included in the price. And exactly similar way as general purpose, you select the core, you select the storage, and this is already enabled by default if you share here. You can disable it, but you don't want to. Similar to SQL, similar to general purpose, you can use the Azure hybrid benefits when you want to bring your SQL Server from on-prem. So that's pretty much it. Once you have done it, you specify various things, and that's all done. You don't need to specify too many things. Apart from that, you would say you want to use Microsoft Intra authentication or SQL plus Microsoft Intra authentication, or just the SQL authentication. So you can do that and support all 3 combination. So that's what it is. I will go back to the slide deck, but feel free to ask me any question you have. No? Okay.
Yeah,
sorry.
right now we're good. If you are listening in, if you have any questions, please drop them in the chat window and we'll get them answered as soon as we can.
Yep. Thank you, David. Yep. Okay, so that was SQL Manager Instance. Just a recap, is a platform as a service option, is covered exactly the same way you have on-prem, where you have a SQL instance, and within instance, you have multiple databases. This is good for, this is specially designed for customer who would like to migrate their on-prem SQL Server instances to Azure. Okay, SQL DB. SQL DB is specially designed for modern application where you want to have a different part of your application could have a dedicated SQL database. This is individual database rather than instance. So the main difference between the two is in SQL managed instance, as the name suggests, it's got an instance, and within instance, you have multiple databases. Now, think about a scenario where on-prem you have, say, 10, 12 databases within an instance. If you want to migrate that SQL instance from on-prem to Azure, you could create one SQL managed instance and you keep all your 10 databases in there. So that would exactly the same. But if you wanted to move them to SQL DB, you would end up creating 8, 10, or 12, whatever number of databases you have. So that's the SQL DB, the individual database rather than instance level. And because this is individual databases, that's why it doesn't support cross DB queries out of the box. There is elastic pool capability that would still allow you, but is out of the box, it just does not support cross DB queries, which is again quite quite common in on-prem, where you have multiple databases in an instance, and most of the databases talk to each other. You have a query which is spanning across multiple databases. If that is the case, then SQL managed instance is the right solution, and that's why, as mentioned, is ideal for customers who wanted to migrate from on-prem to Azure. SQL DB is a database on its own. Like SQL managed instance, this is also platform as a service option, and that means is fully managed, is always on the latest version. You don't need to worry about which version of SQL you're running. You can, like SQL managed instance, you can control core and storage separately. So you can manage your compute and storage separately. Now, when it comes to deployment, there are more than 2 options available here for SQL DB. General purpose and business critical, exactly the same as SQL managed instance. So you have remote storage here, business critical, you have a local storage here. Now, another options for SQL general purpose here is there are 2 ways you can create general purpose single database, either as a single database or elastic pool. So what elastic pool is as the name suggests, is a pool. It allows you to create a pool of resources which could be shared across your databases. So for example, if you have a requirement for an application or 10 applications which in the normal situation, you will create 10 databases, one for each application. And imagine you have got 4 core minimum for each SQL DB, you end up creating 40 core in total for all the databases. Now, in some situation where your application, all those 10 applications not being used or not peak at the same time. So they may be scattered across the globe. So in some places it's being used, which is the daytime. Another places it's not being used because it's the nighttime. So you know that the usage pattern is not the same for all applications, all the databases. In those situations, Elastic Pool is very, very cost efficient and very performant as well, where you create a pool of resources. So instead of 10 databases, each dedicated 4 core, you create, say, 20 core, and this is just an example. So you create Elastic Pool of 20 cores, and you have all your databases sharing those 20 cores across all the databases. And that means, say, out of those 10 databases, 2 are active at the same time, and the 8 are not active at the same time or not peak at the same time. So imagine you have got 20 cores available for those 2 databases. So they will be obviously much more performant, and you're not using the full 40 cores at that point in time. So this is really useful performance. You can also control that, how much core each database should use maximum, so that you don't want to have one database which is very resource intensive, end up using all the code. So you can control that as well. So that's the elastic pool and single databases. Business critical, as I said, is exactly the same. You get read-only replica, and you can create multiple replica as well. There is new offering for your Azure SQL DB at the moment. It's not available for SQL management, which is Hyperscale. And Hyperscale is really good in the sense that they have Microsoft has redesigned the whole storage architecture for Hyperscale. And what does it mean? That the way they store data is different. So if you look at here, you have remote storage for general purpose, for business critical, you have a local storage. In Hyperscale, it's designed in such a way that this is the combination of local and remote storage is used. And that's the reason IOPS is better, because it's got some local storage as well. And another thing is, because of the storage re-architecture, is the amount, the time it takes to take the backup or restore is not directly proportional to the size of the database. So in a normal situation, if you've got 1 terabyte database and you have got 5 terabyte database, to take the backup of bigger database, it will take longer, and to restore the bigger database, it will take longer as well. But in Hyperscale, it's not directly proportional to the size. So it's really very fast to take the back to restore. But also it will allow you to create multiple read replicas. So you can very quickly spin up multiple read replica, and you can point all your read-only replica, read-only queries to those replica. So this is really good. Another thing to highlight is the storage. So there is a limit for 16 terabyte storage here. Sorry, I'm drinking water. So there's a limit for 16 terabyte storage here, but in Hyperscale, it's kind of limitless. At the moment, we say 100 terabyte, but it could go even beyond that. But at the moment, it supports 100 terabyte of database. So it's really useful if you have a very large database. Sorry. Another thing is the elastic pool I've already talked about, so I will skip it. Hyperscale, I mentioned it. I want to talk about serverless. So serverless is the new one. Again, only available on Azure SQL DB. And what does it do is, here you specify, rather than specifying a specific number of cores which you would like to dedicate your database to, here you specify a range. You can say what the minimum core or what the maximum core is available for my database. So depending on the query, it will use the right amount of cores. And then if the query is not running, it will go down. So this is really useful where you have, or your application or database usage pattern is varying a lot. Okay? You know that, for example, in some situation, nobody's using the database, say after 7 o'clock. So then the database will be very quiet. And in that situation, there is a concept called PaaS, where you can specify that if my database is not used for a specific period of time, I think at the moment is 1 hour minimum, but you can say that if my database is not used for 1 hour or 2 hours, whatever you want to specify, then pause the database. And then when the database is paused, you don't pay for compute. 1 second, sorry. I was just having water. So yeah, so when your database is in a pause state, and pause state is not a stop state, the database is still up and running. So as soon as the very first query hit the database, your database is up and running. So that's the PaaS state, and the billing is the per second for this. So that's very cost efficient. And this is really useful where you know that your database is not being used after a certain period of time, or during the day it's only used specific hour. So you can work out in many situations is very cost effective option. So that's the SQL DB. Now I think I'm going to show you again a very quick demo. So let's go back to my portal. So I'm here in the portal again. Let me stop that. Go to the SQL database. Same way, create a new database. And here, this time I want to look into the SQL database. And this option giving you option to choose. You want to create a single database. You want to create elastic pool or database server. Database service is a logical server, and every database you create belong to one of the logical servers. So it's the logical server, it's not a physical object. Okay, so let's pick up a single database. Okay. Exactly like that. Here you have to create a new resource group or pick up an existing resource group. You have to specify database name, you specify your server. I think I had a server before. Let me use that. I will come back to this name, but let me put something for now. Okay, now let's configure it. So this is where the magic is, where you can pick up the one you want. Now, one thing is, I want to highlight another thing is for SQL DB, you have options available for vCore model or DTU-based purchasing model. So DTU-based purchasing model is basically a package of vCore and RAM together. So you don't need to specify how much vCore you want, how much RAM you want. And this might be useful in some situations, more cost effective. Maybe most of the customer I've seen is they use vCore based purchasing model. And as I said, you have got 3 options available for general purpose, business critical, and hyperscale. Let's look at the general purpose. Again, general purpose, for that, you can have a provision and serverless. So look at the provision first. In the provision, I wanted to, you can change the pick up the hardware exactly the same way. It's a different user interface, but it's same thing in the sense that you pick up Gen 5 hardware, or you can one of the premium series, which have a better memory. So you can pick up hardware. Same again. This is slightly different user interface, but same concept that if you were an on-prem SQL Server running, you can use the license for that. You don't need to have to buy the license, and that's why it is saying already have a SQL license. Then yes, then you have to confirm it. Now the next thing you choose is the core, how much core you want, and how much storage you want. So that's what you choose for SQL DB. And here you notice that you can create a database, another database, a zone redundant database in another zone, and that is really useful in some situation where you wanted to have a high availability or replica available, warm replica available, which you can fail over to. You can do that, but there is the extra cost for that. So and that's why this says that for general purpose here, zone redundancy incurs an additional cost. Okay. So that's the general purpose provision one, where you specify. Provision means you specify the core and how much core you want. Serverless, you don't specify exactly how much core you want, but you specify a boundary here, minimum core, 0.5, maximum core, you can specify whatever you want. And the auto pause I mentioned earlier. So you can specify auto pause and enable auto pause. So that means if it is not being used for an hour, and you can specify whatever hour or days, it will be auto pause, and then you're not paying for compute for that time. So that's the serverless. Let's look at the business critical would be exactly the same as serverless, as general purpose. Serverless is not available for business critical. It's only provision options. And here you see that read scale out is enabled, so you are not paying twice. The cost is already included for another instance of SQL DB. So exactly the same, there's not much difference. And finally, for the hyperscale, if you look here, hyperscale, in hyperscale, you specify the core, how much core you want, but you don't specify the storage, you notice here, because it's the auto growth. The storage grow automatically. You don't need to specify here. And you can specify how many replica you want, high availability secondary replica. So you can specify, I think I allow up to 4 replica. So you can specify up to 4 replica. And in order to have a database and zone redundant, you have to have at least one additional replica available. So that's the SQL DB. I hope it makes sense. And I'm almost done. Let me go back to slide deck and very briefly talk about some of the cost optimizations available. You have a Azure hybrid benefit, as I mentioned earlier. You can bring your SQL Server license from on-prem. You have reserved capacities. You can say you can commit to a capacity, whatever it is, to 1 year or 3 years, and that reduced the cost significantly. If you are running your SQL on a dev test environment, the pricing is much less than production. And you can create a license-free standby replica. So that means if you want to create another replica, and you're not going to use it for read-only or read-only queries, you just wanted to use a standby for failover, you can do that, and you don't pay for that. You don't pay the license for that. So that's pretty much. As I mentioned earlier, you have a SQL DB available for free. You have SQL Managed Instance available for free. Feel free to play with it. There's a lots of documentation available. So that's all I have. I'm now going to hand over to Manish, but if anybody has any question, please feel free to ask. Thank you very much. Over to you, Manish.
Thanks, Haider. Thank you. Give me a second. I'll just set up my laptop and start. Let me know if you can see my screen.
Yeah, I can see the screen, but
yeah, that's what I was thinking. Why is it you? Not my screen. Right. Give me a second.
Yeah, I know I'm very popular, but I don't want to see myself.
Okay. Right. You can see it now. Haider, can you confirm?
Yep, that looks good.
Yes.
Okay. And one more thing. Can you see the portal?
Yes.
Okay, good. So thanks a lot, Haider. So please feel free to stop, unmute your mic, and do ask questions if you have. You can always put your questions in the chat, and David, you can help me by asking those questions. I'll be happy to answer those. You can stop me anytime and just ask the question. Right. So we'll now get into the business continuity part. And I'm not sure if the camera is okay, not in a very awkward position. So we'll first start with the business continuity. Haider has given a brilliant understanding of what Azure SQL is and what are the different service tiers in Azure SQL. Now, Azure SQL comes with availability built in. So when you go and spin up an Azure SQL, availability is built in. So we give you a 4.9 of SLAs. So there are few terms which you need to understand before diving into how business and continuity can be designed into Azure SQL. And the very first term which you need to understand is availability. Now, in on-prem terms, normally we used to call it as BCDR, Business Continuity Disaster Recovery Solution. Here in Azure, you should be looking at high availability and disaster recovery as slightly two different things. Okay, so what is high availability is built in. As you can see, an uptime SLA is 99.9949 of SLA, and you absolutely don't have to do anything. That gives an RPO of 0 and RTO of almost 0 as well. The other thing is high availability. This is something which you can achieve by configuring your Azure SQL. When I say Azure SQL, I mean Azure SQL DB as well as managed instance. And you can configure that in zone redundant. So when you create Azure SQL, you can go and select whether you want it locally redundant or zone redundant. And based on that, you also select the backups. Right. So when you have configured your Azure SQL in zone redundant configuration, you get 99.995% of SLA. And the third concept term which I would want you to understand is disaster recovery. And that is where, Heather did cover what is zone in Azure and what is region in Azure. So a single zone can have multiple data centers. So when you go and configure your Azure SQL in zone redundant configuration, that means your primary sits in one zone, one data center, while your secondary sits in another data center. When I say secondary, that is more of a business critical fundamental. In general purpose, it is slightly different. We'll cover that, how it works in general purpose tier. And when we say disaster recovery, it is a different mechanism altogether, and that means that gives you a resiliency of region failure. So that means an entire region goes down, multiple data centers goes down. That is when you are covered, your application is up and running from another region. And disaster recovery is something which you need to design and implement. A very, very basic disaster recovery comes as a built-in, but that is more to do with the backup and restore. So if you have a geo-redundant backup, you do have backup in another region, and you can always spin up a new Azure SQL from there, but it takes like a good few hours to do that based on your database size. If you have a small database, it can be done pretty quickly. Right. So any questions, feel free to ask. Otherwise, I'll keep moving. So what I've done is I divided this business continuity into multiple scenarios. We have taken like 3 scenarios here. And we will discuss how each scenario can be taken care of using in Azure SQL. Now, when it comes to scenario 1 is more of a local hardware or a software fails. That is completely covered, and that comes under HA. So you do not have to do anything if there is a hardware failure, if there is a software failure, it's a PaaS database, it automatically fails over to another node. Now, how it does and what happens under the cover, we'll see in next slide, and that will be only for your understanding rather than anything else, because you do not have to do anything in scenario 1. Okay, scenario 2 is nothing to do with your databases. It is more of an accidental thing. Some data corruption happens. You lose some data in some of the tables. Some row got deleted. Someone has maliciously deleted or accidentally deleted something. How you can cover those things, how you can get your data back is something which we'll discuss in scenario 2. And the third one is the biggest one, which is a DR scene. So what is DR? As I said, your entire region goes down. It is not zone redundant, it is region redundant. So there are multiple ways of implementing disaster recovery. We'll see in upcoming slides, and I'll show some of the demos as well. Okay, now let's take different scenarios which we just spoke about, and what are the different ways you can implement those. Now, very first one is local hardware software failure. As I said, this is built in. You do not have to do anything in this. We'll see how it is built in. The second one is data corruption happened, or accidental or malicious deletion of data or something, or someone has deleted your database entirely, accidentally or whatever. So there are features like point in time restore, where you can go back to a certain point. That depends upon the configuration. A maximum you can go back is 35 days, but it all depends upon the configuration. We'll talk about point in time restore. By default, it is 7 days, so you can go point in time up to 7 days, but you can configure it to a maximum of 35 days and minimum of 1 day. Now, the other thing is long-term retention. Now, a lot of companies have policies that they want to retain a database for longer period, and that can be done up to 10 years. So there are multiple ways of configuring that, and we'll see that in one of the demos. And the third one is if someone has deleted the database, you can still restore it. So when you create Azure SQL, you first create a server, and then you create multiple databases inside that. Unless you have deleted the server, that should be okay. A database can be restored from there. The third one is availability zone, and if the data center outage happens. Now that is something which again you absolutely do not have to do anything once an architecture has been implemented. So in your design, it should be zone redundant, and there is just a single switch which you switch on, saying that it needs to be zone redundant, and your at the back end we deploy that architecture for you. Okay, so your secondary gets deployed in another data center. They are in sync, so you should be aware of the performance and should be testing the performance, because your primary sits in one data center, your secondary sits in another data center. So there will be some latency, which Heather discussed, like less than 2 milliseconds, but it's good to test that. And regional outage is something which DR we talked about. So there are three ways, like Geo-Restore. Geo-Restore is nothing but restoring your backup from a different region. It is normally a paired region where your backup goes. The other one is Geo-Replica. So you can create a replica and just leave it standby replica, and you just leave it for the disaster to happen. That saves your licensing cost. You do not have to pay, but you still have to pay the compute and the data cost. And the third one, which is recommended, is Failover Group, which can be configured as a manual failover or an automated failover. So we'll see all these things we'll talk about in upcoming slides, and we'll also see demos as much as we can. Okay, so very first scenario, as I said, you do not have to do anything. You just have to understand what goes under the covers and how we provide 4 nines of SLA, or we provide 4 9 and a 5 SLA. And those are like financially backed SLAs. So this is the architecture. So first, as Haider has mentioned, that there is general purpose tier as well as business critical tier. Let's first cover business critical tier, because it's very similar to always on availability group. It is always on availability group. But what happens is, if you can see, when you create a primary replica, we create 3 more replicas there under the covers. And these secondary replica, at least one or more, are always in synchronous replication. So what happens is, if there is any issue or any maintenance being done on primary, or some errors come, or failure, hardware software failure happens, it fails over to the secondary replica. Right. Now, this architecture is when it is locally redundant. That means primary sits in the same data center as the secondary. And although there is it doesn't sit in the same rack, so it won't happen that the rack goes down and everything goes down. Unless your entire data center goes down, this architecture works for you. There will be a small blip, and that is the reason why we say that when you go to cloud, your application uh, should be going, and if there is a blip and the connection break, it should retry always. So retry logic is very important when you go into cloud architecture. The other one is general purpose. General purpose tier slightly works in a different way. So when you create a general purpose tier, we do not create 3 more replicas for that. But what we do is we do have some spare nodes, which is again in this particular architecture, it is locally redundant. So within the same data center, you will have some compute nodes waiting for those nodes to fail over to one of these. So if any software failure happens, any other failure happens, what happens is your primary replica uh, switches over to one of the spare nodes. Another big difference between this and business critical is, if you see the business critical, they have local SSD sitting next to the compute node. What does that mean? That means all your data is replicated in four compute and SSDs. So there is a seeding happening, and there is a continuous replication happening between primary and the secondaries. But in general purpose, your data and log file, they sit in a premium storage, which is removed. So what happens if a primary fails? One of the spare secondary nodes gets your data files attached to that node, and then it is up and running. So another difference between these two is, in business critical, your compute node is always online, so it is hot. While in general purpose, you have a spare node which starts cold, so you have lost the cache. Your spare node gets connected to the database files, but there is no cache because primary has failed over to one of the spare nodes. So that is the main difference, and that is but we still provide you 4 nines of SLAs, whether it is business critical or general purpose, because there is always a spare node to fail over to. And from a data perspective, the redundancy of your data in general purpose is managed by the storage account. So your storage actually keeps 3 copies of the data, while in business critical, we keep 4 copies of the data in all secondaries. Right, so that is architecture difference. Again, you do not have to do anything. It's been done by us. And all failovers happens. There would be a small blip, but you do not have to take any actions. Similar architecture, if it is zone redundant, you can see the control ring is redundant as well as your primary and secondaries. In both the cases, if your primary sits in AZ1, which is in one data center, one of the secondary would sit in the same data center, while two secondaries will sit in AZ2 and AZ3. So this is how we provide you zone redundancy, and that is where we give you 99.995% of SLA. Similar in general purpose, it is your spare nodes are waiting to be failed over to in another region, and your premium storage where the data is, that is zone redundant as well. So that is how your zone redundancy work. Again, you do not have to do anything other than while implementing, while creating an Azure SQL, you just have to say that you need a zone redundant, and that is how the deployment happens at the backend. Right. So scenario 1, I hope you guys understood. If there is any question, David, let me know. If not, we can jump to scenario 2.
Will do. We've got one question for you to display a slide, but we'll do that at the very end.
Okay, not a problem. Thanks a lot. So second scenario is when you have a data center outage, your entire data center goes down, or sorry, when you have a region outage as well. So data center or region depends upon if that region has one data center or more. So based on that, that's why I've put as Azure data center / a region. This is the disaster recovery solution, and by default you can have the most basic as Geo-Restore. Geo-Restore is your database runs in one region, your backup happens automatically, and the backup is stored in another region. So if the entire region goes down, you have a backup in another paired region. You can go and spin up a new Azure SQL managed instance or DB, whatever you had, and then restore it from the geo-redundant backup. Okay, the RTO is 12 hours and RPO is 1 hour in this case, although this 12 hours depends upon the size of your database. If you have a huge database, then restoring from a backup may take longer. Okay, the other way is manual failover. What does that mean? You have created one database in one region, you have created another database in another region and put it in to synchronize. So we'll create a replica of that. So that is continuously replicating, although async replicating. It cannot be synchronous replication, otherwise you'll see a performance hit. And you can fail over your database manually as and when you need. Okay, so RTO is 30 seconds and 5 seconds. So there might be slight data loss because it is async replication. And auto failover group, which we recommend you to go with, and that can be configured manual as well as automatic. If you have gone with an automatic failover group configuration, I'll show you how to do that. There is a lead time of 1 hour. So we'll wait for 1 hour before we'll fail over to another region. See, disaster is a huge, big thing. Normally, when you say disaster, that means the entire region has gone down. It's not nothing to do with one rack or one data center. So we need to wait and be sure that, okay, this region has gone down and it's not going to come up any soon. There is no technical difficulty. We can always fail over, but we really want to make sure that all the data has got replicated to the secondary data center, secondary region before we fail over. Right. So the second thing which I said was manual database failure. And the third, auto failover group. In both these cases, you'll have to create a replica in another region, and that replica can be a standby replica for disaster recovery, or you can have a geo-replica. So what is standard replica? Standalone replica. Standalone replica is you confirm that you are not going to use this replica for any other purpose than a disaster recovery. That means you cannot run any read-only queries on that. So that is a standalone replica waiting on another region. If something happens to this region, you have a replica which is asynchronously replicated, and you can switch over your applications to point to the another region and you're up and running. So if you go with the standalone replica, that it saves your licensing costs. So we do not charge you any licenses for that, although there is a charge to the compute because compute is associated to it. There is a charge to the storage because your entire database sits in storage account. But if you go with the Geo-Replica, we charge licensing cost as well because Geo-Replica can be used as a readable replica. So what you can do is you can have a read-write on your one region. You can have a read-only workloads running on the secondary region. So you're using both the replicas constantly, and that is the reason why licensing cost comes up with. And the third one is failover group. So this is an architecture of failover group. What you do is you create a replica and then you create a failover group on top of that. And then you say that, okay, it has to be a manual failover. I'm going to do a failover. Or you can say that, okay, it can be an automatic failover and Microsoft can fail it over after an hour or based on whatever lead time you select. So it's better to go through and see these rather than talking. So I'll just jump to the portal. So what I've done is I've created a server and then a database. Okay, so if I go into SQL database, this is where on the left pane under the data management, you can see replicas. So if I go here, I can see there is no replica created at the moment. I've created this database on UK South, and let me create a replica at another region. So I'll create a replica, and it asks you whether you want to go with the Geo-Replica or you want to go with the standby replica. Let me go with the standby replica, and I'll confirm that I'm not going to use this replica for anything else other than disaster recovery. Now it says server is, because it is the server sits on edge on the UK South, I'll have to create a new server. So I'll just create a new server in UK North. You can see North UK. UK West, sorry, I've got a habit of saying UK. It's Europe North. Okay, so I'll create a replica over there. Okay, it is ready to be created. So let me click OK. And I'll just review and create it. Right. So this replica will get created. Once this replica is created, that is when we can either do a manual failover, because this replica is the replica to the primary database which you saw, and both the databases will always be in sync, although asynchronously replicating. Okay, I can go and manually failover if I want, but the recommended way is to create a failover group, add these databases there, and then configure it to be automated failover, so that Microsoft waits for that lead time and fails it over by itself. So we'll come back and see the failover group while it is getting deployed. I can't show you now unless the deployment completes. So let me go back to the slide deck, move to scenario 3, and when we will come back for the demo of scenario 3, I'll show you how you can create the failover groups there. Right. Now, the third scenario is just a data corruption that has happened, or accidental deletion of the data. I said there are multiple ways of doing it. One is point-in-time restore. The point-in-time restore is you can go back to whichever point in time you want to go back to. For example, a deletion has happened like an hour before, so you can go an hour and 30 minutes before, or you can go like up to 35 days based on the configuration you have done for your database retention. I'll show you from where you can configure. We give you 100% free storage, which is equal to the size of your database. So you have to be very cautious about configuring your retention period. You can't just go and put it as 35 days, because it will start charging you about the storage. For example, if you have got a 2 terabytes of database, you get 2 terabytes of free space to keep your database backups. Now, if you have a 35 days as retention period, it won't be 1 or 2 or 3 backups, isn't it? It will be multiple backups, and that will be more than 2 terabytes, and that will be charged to you. So depending upon your company's policy, what you feel it is optimal, you can configure retention period of 1 day, or by default it is 7 days. So when I create an Azure SQL, by default it is 7 days. I'll show you from where you can go and change it, but you can configure between 1 and 35 as your company's policy says. But whatever you have configured, that will be the retention period or point in time restore. You can go back to that point in time. I don't think you'll ever go back like 35 days if any deletion happens, isn't it? If it's a production database. So if you go back to certain instant, how it works is it restores your database in the same server. So you'll have a production database, you'll have another database, and that is when either you rename the new one as the production, or copy that data or remove that corruption whatever has happened. So your 30 minutes back database had those rows which has been accidentally deleted. You go and do a point in time restore. We create another database for you in the same server. Now that rows is available in that restore database. You write a script, copy those data to your production database. That is how it should be working. Now, long-term retention, again, I'll show you how you can configure long-term retention backup, and that can be stored like for 10 years. It all depends upon your company policies, your needs. Configurations are pretty simple. I'll quickly go and show. Restore deleted database, I'll again show a demo on that. What I've done is this afternoon, I have created these two databases for you, and I've deleted one of those. So we should be able to see those, the deleted database and how you can restore it back. Right, so I'll go back to portal again. Okay, this deployment is complete. So we'll see all three of those, all demos. And so you can see now two databases and two servers. Right. Both the databases names are same because your application will ping into one of these databases, whether in this region or that region. One sits in UK South, other one sits in UK West. Right. So let me go to the server first. And this is where you can create your failover groups from. So let's first complete this. You can add a failover group from here. At the moment, there is no group configured. So what I'll do is I'll add a failover group. I'll have to put a name. Okay. Give some more sensible name rather than what I have given, but this is just for demo. I'll select the new server. Okay, there is not configured yet, so there is no database configured yet. So I'll configure database and select this in the new server. Then, okay, so you can now see that one database has been selected, and now you create a failover group. It is deploying at the moment. Once that deployment completes, that means both the database, you have created a failover group on both the databases, and we can see how you can configure that. Once that deployment completes, I'll show you. In the meantime, can we go back to the resource group and show you some more demos? So again, I'll go back to the server. And let's get into the backups. Okay, deployment completed. So let's go and see the deployment first. So okay, you can see this new failover group has come up. If I get into this, you can see these are the two regions which are it's very close to each other, so you can't see much. These are the paired regions, but currently your application is running on the primary application is running on UK South, and secondary is UK West. You can see the read-write listener endpoint here and read-only listener. At this moment, you can use both because it's not a standby replica, so you can use the read-only listener from here. Right, and if you want to do a failover, you can always do a failover or a forced failover. A failover is when both the things are running and due to some reason you want to fail it over to another region. A lot of companies, what they do is they do have a policy that they'll run the production environment 3 months from one region, 3 months from another region, just to make sure that both the regions are up and running and there is absolutely no issues if any disaster happens. So failing over is pretty simple. You just go and fail it over. Now there is absolutely no data loss in this case. It will make sure that all the data gets replicated. If there is any transactions in middle, it will make sure that transaction gets committed, hardened in your primary, move to secondary. It has been hardened over there, and then it fails over. Since I haven't run any transactions, so it will be a straight failover as soon as because there is nothing to apply. Right. Forced failover is more of something has happened in your primary, and now you have to force failover to your secondary because something has gone wrong in primary. But that is something which you can have a loss of data because you're forcing this failover and not allowing Microsoft to do due diligence whether all the data has been applied or not. Right, this is all manual at the moment. If I go and edit configuration, it shows on the right that this is customer managed. If you want Microsoft to manage it, that becomes an auto failover, and you select a grace period of 1 to 24 hours, whatever you want. Minimum is 1. So if I do this, so my configuration gets updated. Now your database, two primary and secondary databases are in sync, and it fails over automatically after an hour if we find that disaster has happened in region UK South. Right, so I'll do this and I'll just save it and move on. It has been so that it's that simple to implement a disaster recovery solution in Azure, whether it is SQL DB, whether it is SQL MI, both works same. Right, let's go and see some of the backups which we talked about and how we can configure those. So if I go to the backups, you can see when I created the latest backup is available of today, 8:26 UTC. So that means I can go back to up to this time, right? I'll show you how you can create you create a PITR in a moment. But first, let's see the configuration of the backup policies. As I said, retention policy by default is 7 days. So when you create a Azure SQL DB, the default PITR days is 7 days. You can go and configure policies. You can change it to 1 day, or you can change it to 35 days, whatever your requirement is. I'll just put it as 1 day. I don't think I'll ever go back more than a day because I'll be losing a lot of data otherwise. And differential backup, you can select whether you want to do a differential backup in every 24 hours or 12 hours. Okay, now this is PaaS database. You do not have to take any more backups. So we do the backups for you. And the normal schedule is like we take a full backup every once in a week. We take a differential backup every 12 hours. That's the default one. You can always go and change it to 24 hours. It depends on you. If whatever the configuration is, we'll take a differential backup then. And then we take transaction log backups every 3 to 5 minutes. But that depends upon the number of transactions that has gone through. If it is highly busy system, probably we'll start taking transactional backups much earlier than 3 to 5 minutes. But it all depends. If it is it's not been used at the moment, nighttime, it's a lean period, we'll take the transactional backups based on the usage. Right. Now it comes to the long-term retention, which I was talking about, that you can retain your databases for around 10 years or something. So there are multiple ways to configure. Depends upon your company policies. Like you say that I want to keep a weekly backups for 1 year. So every week a full backup happens. As I said, every week a full. Okay. One more thing, long-term retention only keeps your full backup. It will never keep your differential backup or transactional backup. So when I say keep 1 year, that means every week when a full backup happens, that is stored in long-term retention, and it gets deleted after 1 year. Okay, 13th month, the first backup gets deleted. 14th month, second backup gets deleted. Similarly, you can keep the monthly backup. You can keep a yearly backup. I want to keep every week's backup for maybe 6 months, and then I want to take a backup, or rather, this looks more sensible, isn't it? I'll keep for a year every week's backup, or we can do like 1 month. And then LTR, we can put it as annual backup. Just take the backup of last week of the year, and just keep it for maybe 10 years. So this configuration, what it will do is it will take week 52 backup and keep it for 10 years. Once you are done, you can just apply it and save it. So your configuration gets saved, and now every backup, a weekly backup gets saved for 1 year, and every yearly backup is saved for 10 years. So that is how you can configure your PITR and LTR, long-term retention. Now, how are you going to implement in case any in any accidental deletion happens? As I said, you can do a point-in-time restore up to a configured duration. I've configured it as 1 day. I've just changed that configuration. But this is your UK South. This is the primary. Okay, I failed it over to secondary. This is secondary at the moment. But anyways, I can still do a restore. I can do a PITR. So this is the restore button you can see over here, from where you can restore a database. Now the scenario is you have a database, an accidental deletion has happened, or data corruption has happened, a table has got corrupted, or some pages have got corrupted, or whatever, and you want to go back like 30 minutes. You'll go click on restore. It asks you, where do you want to get that data from? I can select point in time restore. I can always also select long-term retention backup as well. So for point in time restore, you can say, okay, it's 7:18 p.m. Please go back to 6:45 p.m. and then create a new database with whatever name it has given. It some name. You can always change it to whatever you want. This database to restored, and then review and create. Okay, so when you review and create, another database comes up, and that is when you can always get the data back from this restore database, right? I'm not going to create because there'll be a lot of databases over there, and unnecessary consumption starts. So I'll just go back. You just have to create, click on the review and create, and it gets created. Right. We did see PITR, we did see LTR. What else? Geo-Replication failover group. Okay, Geo-Replication is nothing but that replica which I created, which I showed you. And what was the other ones? Okay, this looks like a different copy of slide deck. I'm so sorry for that. But yeah, I think these were the demos which I wanted to show you. And okay, deleted database is another one which I wanted to show you. So we'll go to the server. So you always remember that server sits on the top, and then you create a SQL server. When you see type, that means it's a virtual container kind of thing. So you create a virtual container, and then you create databases underneath. So I'll go to the SQL Server. I'll go to deleted database. It will show all the databases which has been deleted. So I said I've created a demo database and I've deleted it just for the purpose. But this could be an accidental deletion by one of your team members or DP or whoever has got the rights to do that. So you always go here, select this database, and restore it back. So when I click on review and create, what will happen is it will create the same the database into the same server. So you can't change the server. It will go to the same server. That's why I said until you have deleted your database as well as server, it can be restored. But if you have dropped the server itself, the container has gone, database has gone, it can't be restored, right? So that is how your restore database would work, right? So that is what I would wanted to show you today. Any questions, please?
Yeah, I've got one good question here. Is the procedure commit and reprotect applicable to SQL databases?
Is the procedure what? Sorry, could you repeat?
Yeah, is the procedure commit and reprotect applicable to SQL databases?
So I didn't get that question. Where are you going to do that? Is it in the application level?
I'm not entirely sure. Kevin, would you mind either coming off mute
Yeah,
and
please.
asking, or just putting some more details in the chat here?
Yeah, please, if you can, unmute yourself and ask your question. That will be helpful. I would need some more information to answer your question. I'm so sorry for that.
Oh, no worries. In the meantime, there was one request to show the slide prior to the solutions to business continuity scenarios. It was at the beginning of your slide deck there.
Okay, the header slide probably. This is the one you want. Sorry, which slide do you want?
It was the one before solutions to
Just
business.
one before.
Correct, yeah.
This one. Yeah, what was the question on this?
I think that was it. If
Okay.
that, Kevin, if that was not it, this will be up on YouTube tonight. Feel free to go ahead and check it out there, and that way you can get exactly what you're looking for there.
Yeah, just to if commit, maybe it's talking about commit is used in Oracle to commit a transaction, basically your option rollback or commit. So maybe the question is whether you need to commit a transaction. I assume that
Before what? Sorry.
the commit to the
Okay, I'll take that commit. Yeah, before what? Can you repeat the question now? Probably I'll try to.
Is the procedure commit and reprotect applicable to SQL databases? So I was thinking about maybe referring to Oracle, where you have commit and rollback, specifically to roll back a transaction or commit a transaction. So maybe the question
Is it related to the failover case? So yeah,
we got
commits and rollback happens in SQL as well. If it is
okay, we've got some more details here. He remembers after failing back, there was a procedure of commit and reprotect being done in the company's DR drill in the past. Not sure if that was done on SQL though. And basically not rollbacking. Kevin, I think I have an idea what's going on here. The reprotect portion, or to essentially not roll back, I think it's because they may have taken your DR environment and promoted it to active, but blocked the data from getting back to the primary. So that way during testing and things, you didn't interrupt anything. And then when the process was done there, they essentially get rid of the DR test bed and let data resume replicating. I think that's more what's going on there. And the interesting thing is you don't really have that much of an option with the SQL DB. You can take database snapshots, represent them as new databases, things like that, or backup, copy, restore kind of stuff.
Yeah,
it's honestly, I'm actually preferable to it because it gives you more impunity to do anything that you want without risking damaging anything else.
Yeah, and if it is related to that, if a disaster recovery happens and your database and server fails over to a secondary node, do you roll it back after your primary region has come back? So in that case, no, we do not do that. It won't be an automatically recovering back or rolling back to the primary region. That has to be done by the customer, because it all depends upon when you want to go back to the primary region, which has come back now.
Makes
If
sense.
that was anything to do, I just added that.
Yeah, no, it makes sense. I mean, basically, if data is changing, you just need to be really careful to make sure you don't lose data.
Yeah.
That's the bottom line. Okay. Are there any other questions or thoughts from anybody? And feel free to come off mute and turn on your cameras and say hi. If not, I would say thank you guys both for presenting today. This is awesome. It's a lot of fun. It's always good to have some good folks from Microsoft on with us.
Thanks a lot, David, and thanks everyone for joining. I hope you liked it and it was helpful.
Oh, that was fun.
Yeah, thank you very much. Thanks for the opportunity and hope you found it useful. And feel free to reach out to us if you have any question. You'll find us on LinkedIn.
Absolutely. Thank you very much. And for everybody that was able to take the time to join us today, thank you. If you're watching this after the fact, if you have any questions, let us know. And we look forward to seeing you all in the next one. Thank you very much.
Have a nice day.
Excellent.
Bye.